Alright. You go first? Yeah. Alright. We have completely modeled our robot. This robot is before we even started building, we built it into the computer so we would know what we're doing. We ran into several problems with the way we were trying to do it. We have here a system for the weighted rings. See, we put a weighted ring in here, a light turn on, so that we can know without in the program. It's a simpler way to tell whether it's heavy or light. So we did solve that problem. The only problem is we found that the weighted rings do not give us any extra points. It's actually better to carry 2 rings at a time and put them on the board, because you get more points that way than trying to do the extra points, especially if your other team is not good at scoring. If your other team is good at scoring, then we may switch out for this one so that we can get weighted rings, and then we get a bigger score by increasing it by 20%. So we found many problems with our design that this piece, with that, it's heavier, so pushing this in and out, because we have a scissor here, so we can get a robot to be bigger, so we can stick out, so that we have an extra bonus, so whenever we go into it, it grabs the peg better. So it's too heavy, so we had to use 2 motors for that one. This one's much lighter, so it's easier. We also had to do dual motors here to lift it up and down. You want to go, Josh?
Yes. This is what he's referring to as the dual motors. Turn it sideways so they can actually see it. There's a cable system running around. It's basically a genie lift, but it's simplified down to the raw form so that we can get easy and quick maneuverability up and down, being able to get the rings up to the top. That was one of the things that we really wanted, because most of our scoring is based on getting line bonuses, so we need to make sure that we had maneuverability to every peg possible. And with this lift system, we have the ability to do that. That was our original robot design, and as you can see, we added quite a bit just before the original.
That was just to learn how we were working. We also have a very unique feature that other robots do not have, because we built them ourselves. We have Metinum Omni wheels. They're different than just Omni wheels that the Tetra kit has. We built these entirely ourselves. We machined every part and bent them. These allow us to strafe back and forth. We have a program in here that will show you that if you don't mind. Okay. All right, can you move this one? Yep. All right.
It was actually designed for the competition floor. It's not ground properly, but we'll see.
How'd you come up with that?
We saw them on the internet. They sell them. They're like $50 a piece, and we're like, we can't buy them, and they're also too expensive for us. So I was looking at them, and I decided that I would try and model them up. So I did, and this is what I came up with. This is the easiest way to make them, and we had the arc at 7 degrees on every side.
And if you have that page, there should be some more diagrams of the wheels.
Yeah.
What's the advantage you were looking for with that design?
Is whenever you go up to try and lift and get the rings off there, if you're off, you would have to back up and go in and back up and go in every time to try and get lined up. Here we can just move back and forth to get lined up, so it saves us a lot of time.
This is in the programming, this is the trigonometric code that we got from internet research.
Set up so that at the end game, it's relatively simple to build, and there's no motors or anything we added. We have it set up to the proper height where we literally just back it up against one of the ring mounts. Obviously our own, because we touch our opponents, that's penalty. But we do it on our own and switch it, and it can hold a significant weight. We actually were talking with the team, I don't remember the team number, but they had the heaviest robot here. It was a 55-pound robot, and we're going to see later, hopefully, if their robot will actually fit on this. So it should be capable of doing that.
We also, in the autonomous, we were finding that to try and line up with the top, because we do have a program to put the ring on, it doesn't actually find the beaker, which we have the sensor on here, but it doesn't use it. But we can put it on. And in order to do that, we square up with the board, the actual tic-tac-toe board, and then we put our light sensor down to find the white line, which then aligns us up to put it on. So it's much more accurate. And then we also had to add a touch sensor on this side to say that we're all the way down, because otherwise we would go too far.
As you can see, the touch sensor is right here, and we slightly extended it so that we we could have it stopped earlier so that wouldn't go past the point of being all the way down and come off of the spool that we have at the back to pull it. And right now we're running I believe he's running our program to.
We're just looking at and see, at its maximum height, we have it so that it's about this much more than we actually need.
Yeah, the peg is about right here, so it's more than we need.
So we have full maneuverability on the field. We can get to all the peg mounts. We can get to the bonus one in the corner. We can get to the center one. We can get to the top one. Literally anywhere we can put it there.
And we also have a program written to bring it down to display the touch sensor. It'll bring it down until it finds the touch sensor.
Because we found that sometimes it messes up and then we have to fix it, so we had to add an extra program to help us complete our tasks.
So go ahead and run that.
Yeah.
And it can translate X or Y autonomously? Or is that something
It's
you do
used as
like-
encoders, so that's how we say move this many clicks this way and this many clicks. We found that using the gyro sensors and those sensors, they're so inaccurate that they don't really help.
And then what happened, we just saw this piece right here, hits the touch sensor, which tells it to not go any further. Because the way the Genie lift is set up, there's a spindle back here. Actually, you can see it because of the panel, but you can see it through here. It's a spindle, but it'll keep moving. And what we're coming with is we'd have problems with the wiring here slipping off of it. So that eliminates that issue. It will bind up time to time, but we just made some recent modifications today so that it will not do that anymore.
Yeah, we also have a tensioning spring, similar to a bicycle, to keep the cord tight, because we found that the touch sensor doesn't respond quick enough. So it has a lag, so the string will come undone, it gets loose, and then it gets off the spindles.
What kind of outreach have you guys done?
We went to the first LEGO League in Cookeville, and we showed off our robot.
We did some displays of just driving the robot around. We had the people that were there, the children, if I dare to say,
We fed
hold
people.
out their fingers, and we placed rings on their fingers. And we also
We fed you.
fed someone
We fed
with
you.
our robot.
We also did some recycling.
Yeah.
We threw away
had
people's
people
trash.
Put trash in our robot and we throw it away.
We put a honey button into the bucket and then he got on his knees and we jammed it into his mouth.
It hurt.
We also,
People loved it.
we mentored a first LEGO League team, Team Brainstorm, was my old team, and this one's a cool team,
Mhm.
Josh Freiber's. And we also helped mentor an FTC team, NXT 360.
It
We
was,
helped
it was an X.
They're in
NX
Knoxville.
360. They're in
Tennessee.
Knoxville,
And
Tennessee.
then also there was a team in California, I believe it was,
Yes.
that was very interested in our wheels and our design. And so we helped them create a similar design so that they could have the,
We sent
same
our
abilities
design
that
to
we
them
have.
so that they could use our design.
What grades are you guys?
I'm-
Freshman.
Just go on.
Freshman.
I'm a freshman in college. I actually graduated early, which is why I still qualify for this.
Sophomore.
I'm a junior.
Freshman.
Everything's covered, good.
How did you raise money?
We went out into the public and got,
Yeah,
we,
all of them are on.
I brought several of the American stainless pumps and several auto plates, I think, were brought in from my FLL team, because I did FLL for 4 years. They moved up with me. Then we have First sponsored us with a scholarship, not scholarship, but First sponsored us because we applied for it and because we were a rookie team, so we were able to get those. And then his dad worked for EDO or
Yes.
Edo. We got those. Several of the companies that our family and stuff work for, we
And then
went to.
Also, this year they were unable to sponsor us because our robot was basically complete, but we had a guy from, was it the local Air Force Academy?
Yeah, it was
He
the
came
Air
and
Force.
said next year we'll be sponsored by them.
Because they can
as well.
buy us stuff. They give them so much money, and they can buy us stuff. So if we needed metal, they could buy that and be sent to us. So
So next year you'll see a full big Air Force just all over this.
What was the biggest thing for you to move, transition from FLL to FTC?
I'd say probably being able to use raw materials. That was probably the biggest thing that we could do because it opened up our capability of building robots. As you can see, we pretty much build everything ourselves. We have very minimal tetric pieces.
It was very helpful to have an idea, and wherein FLL, we would have to say, okay, how can we make this using Legos within this design? Whereas now we can say, now we can make pretty much anything because we can bend the pieces how we want. We can angle things certain ways that would be impossible with the Lego pieces.
Also, the programming in itself is different, just a totally different user system altogether.
It's
I
less-
I programmed the robot in FLL, but this stuff is, you know, the programming, I understand it, but this guy's a programmer right now.
It's also a lot less glitchy. It's not, there's not as many bugs in the program.
Yes, that's fun. FLL was fun fixing all those bugs. But I mean, it's cool, just being able to do like prototypes and stuff. I mean, you can see with our pictures there, we went through several different designs, several different modifications. I think we originally started out with like just basic wheels, and then when they came up with this wheel design, it was so much better because we could strafe. Originally, we didn't even have a ramp on the robot. We were just like, okay, we're gonna forget about ramping up because it's only 30 points. And it was like, well, wait, no, we have room, we can do this.
We also, in the beginning, we had a ramp, it was up this high, we found the angle was too much, and we had a plate that went all the way back, so to get the robot actually higher, but this angle was too much, so we didn't think robots could drive up, but now we find most of the robots here probably could have, but our robot cannot, because it couldn't drive up more than like a 10-degree angle.
How many
Also,
members do you have on the team?
This
All
is
of you?
this is all of our team.
This is all of our team.
I would like to say for a moment that the teleop phase was a major transition going from FLL, which was fully autonomous, to FTC, which had the phase where we could control the robot in real time. It was very interesting to program the controllers and to find out who was best at controlling the robot in certain situations.
So do you switch off depending on?
Well, right now it's this guy right here, Chandler and Josh Freiberger.
But we do
They're-
have several rotational periods.
Yeah,
that
we
different people will
everybody can drive. These two are the best. They put up a 305 score on the
315.
board. 315? 315 score on the board.
in practice,
In
with
practice.
only our robot on the field, which I hope that we'll be
This
able
is
to
a health
replicate
program.
when there are other robots present.
And that's like there's 3 or 4 pages now.
What are one of the core things about FTC?
Pardon?
we are a team.
Could you say the question again? I didn't hear it.
What is one of the core values of FTC? and-
Oh, core value? Just being able to be team with everyone.
Gracious
and
professionalism.
consistent
Mhm.
people. We
What
had
does
people
it
come
mean
up
to you?
today and ask us for supplies, and we were like, yeah, sure, we got extra. If we got it, we can
Someone
share it.
came up and asked for some wires, they forgot them or something. We allowed them to use it. We help others. We helped another team that we may compete against if we go on to the next level. And if they make it as well, we may lose to them, but we help them get to where they are.
What does that mean to you in terms of team dynamics?
Helping, yeah, go ahead.
Well, that's one of the things I really like about FTC compared to FLL. In FLL, it's basically you're on your own. You know, you might get, you know, one assistant, but they're kind of divided from you. I really like the teamwork in FTC because we're working with teams. It's not like, you know, we have to beat this person. It's like, no, we need to help each other. We need to progressively, you know, figure out what robot does what, figure out how their robot matches with our robot, how ours can complement theirs, how we can do different situations better.
And in the reference to gracious professionalism, when we were originally setting up our playing field for practice, we only bought one set of rings because we knew that they would be selling out quickly, and we didn't want to take the rings from another team that wouldn't be able to practice if they didn't receive them.
And we were right, because they sold out very quickly.
And also, we did have a few problems when we arrived with getting our robot to switch over from autonomous to teleop. We've got that now, but we did have to get help from another team. So the spirit of British professionalism that's in the air is it's a wonderful thing to be there, to know that we can receive help if we do need it.
What's with the headgear?
Oh, gosh.
We are RPG, which is commonly known for role-playing
Role-playing
games.
games.
As in Dungeons and Dragons, we use it as Robot Programming Guild. It's a bit of a pun because puns are amazing. But this is a reference to Dungeons and Dragons. It's armor grade chainmail, which is the armor that they would use in medieval times, and it's handcrafted like our robot.
Tell them to wait.
Did you make this
Well.
up?
Yes, I did.
And we are out of time.
There's a pretty good Gangnam style. I saw him in the gym.
But thank you very much, gentlemen. Appreciate
Thank you.
Thank you for your time.
Thank you.
Have a great rest of the
It's
day.
Laverne near.